LED blink program. So the main program is actually quite simple. We'll be utilizing the knowledge that we have learned on delay. This is the delay portion, which we learned from chapter 2. And this delay portion will be done using subroutine. So that is also knowledge from chapter 4. And of course, we are using input output ports. So for that, we need to know how to configure the port 3 register. So here what I've done is, this is actually the main program. So in the main program, as you can see, first thing I'm using port B. So we're going to use 8 LEDs, then we're going to write a program to make the LEDs blink. So first of all, I made clear F3B so that all the pins in port B will become output. And then here I'm using calling a subroutine by the name delay. Now this delay subroutine, if you are seeing this, now this whole program is actually what we have learned in chapter 2. This is a delay or a loop which creates 0.5 millisecond delay. So instead of writing this portion in the main program, and since I'm using this delay in a repetitive mode, so that's why I'm making it into subroutine, so I can call the delay each time. So here what I've done is I have called the delay twice, which means I am actually delaying for 1 second. So first thing what I'm doing is I'm delaying the program for 1 second, and then I set F port B, which means all the LED in port B will be turned on for 1 second. You see, after the setting of port B, I call the delay twice, which means I'm delaying it for 1 second. So after 1 second, I clear F port B, which means all the LED will be off, and branch repeat. So which means the LED will turn on and off for every 1 second delay. So the delay subroutine is here, it's all program, as you've learned before. And if you notice that we are calling this duplicate no operation macro. So the duplicate operation macro is defined on top here. This is a duplication no operation macro. And of course, I'm using this loop count. Just declare it or assign it to address 00, which I'll be using here to decrease the loop count. So this is actually a simple program. So after we compile and everything, make sure it's successful. So next thing, later we'll come back to this. The next thing we need to do is just minimize this. So I'm sure that all of you have downloaded this Proteus 7.7. So just open this. So you can see there's actually a readme text here. If we open this, it's actually courtesy of one of my students. So it's a very easy instruction. The first thing what you need to do is you need to change your computer or node time zone to -8 before you open the ISIS. So how to do that? It's quite simple. Just go to your time, change date and time settings. So here you just click the change time zone, and the time zone setting, scroll up until you see -8. So you see UTC -8, Pacific time, US and Canada. So just select this one, click OK, and now you can open the ISIS. So double click on it. It's loading. If you never change the time zone, then you won't be able to use this Proteus. So this is actually the main layout. So we can immediately start to construct our circuit. So for that, this is the component mode. Click on the component mode and just click on the pick from libraries. So you can see here pick devices. So as you can see here, there's a lot of categories. So we will search under microprocessor ICs. If you double click on this, will have a lot under the subcategory. So for subcategory, we are going to choose PIC18 family. So as you can see, there's a long list of devices. So we are searching for PIC18458. So you can scroll down. So yes, we have it here, PIC18F458. So after clicking OK, then click OK. So you can see now your mouse cursor becomes like a pen. So if you do the left click, you can see diagram like this. So you can just drop it here. You can actually enlarge this. So you have this PIC18F458. Now we're going to, in order to make this work, this pin number 1, if you see is VPP, you need to connect this pin number 1 to 5 volt. So if you want to select the terminals, so if you go here, this icon actually represents the terminal modes. So click this. So you already have few terminals here. So the terminal that we want is the power terminal. So double click. I'm sorry, you don't have to double click. Just click on this power terminal and can start drawing. So you have the power terminal and you just bring over and draw the wire. So right click on this, edit properties, then you can type +5 volt. Click OK. So now you see this +5 volt. So now you need to connect this to 5 volt in order for this microcontroller to work. Now next thing what we're going to do is we're going to connect LEDs to port B, this port. So for that we need animating LED, and also we need a resistor value of 330. So again we are going to go back to the component mode. So click on the component mode and you pick from library. So now we just type here under the keyword, type LED. So as you can see, there's a lot of LED displayed. So if you see under the results, sort of LED. So what we're looking for is animated LED model. It's the animated LED model. So let's choose a color. Let's say green. So we'll choose green LED. So you can see the schematic model here. So we're just going to click OK, and you can start drawing LEDs. So we want to rotate this clockwise. So we have this, and draw another one, and another one. So we need total of 8.